we
Yeah.
can start the recording. All right.
Ma'am Marlene is replying through
Through
chat.
chat. Okay. Yeah, I can see that. And so we'll just, so I'm gonna start now. So I'm gonna share the screen and from my desktop, and then you'll be able to see, that's my alarm from my phone. Okay, so let's start by reviewing the syllabus so that we can all have a good bird's eye view of what's expected and what's going to happen in this quarter. So this is a continuation of the EPI and Biostatistics class 101. And that was pretty much a primer to this course. This is your second series of graduate level application of advanced statistical methods and analysis for neuroscientists. So when I sat down with Madam Cisno and on what are the needs of most of us who are nurse, and in the strongest sense, we are going to become scientists when we are PhD prepared. And so I have selected very specific advanced statistical methods and analysis that hopefully will be very applicable to your dissertation and help you achieve your doctoral studies and complete your doctoral studies. So these are advanced statistics that will look into biological, epidemiological, especially logistic regression, because that's a binomial categorical variable. And then we're going to look at psychosocial and healthcare delivery system scientific inquiries. So that's really the course description of this advanced statistics. And I'm also going to just have in this session, we will look at why do we call this advanced statistics and what is really basic statistics. So
Hello, good morning.
hi, good morning, welcome. That's good.
Happy New Year.
Happy New Year indeed. So I think so here we are with so what are the course objectives? The course objective is quite ambitious here. We'll try to achieve this as much as possible. And but as I've said, it's quite ambitious because I tried to combine the other objectives. In the United States, there's actually 3/4 of statistics, and we are making it into 2/4 in the Philippines. And so
good morning, Dr.
good
Karina.
Hi, good morning, welcome.
Okay, how are you?
I can see all of you, so that's very good. So so the first course objective is that you'll be able to explain statistical modeling for theory development and theory testing. So again, as most statisticians would argue that advanced statistics involves those statistics that's already starting to look at models. Are you modeling your statistical approach towards prediction or towards just association? So we're gonna really have a very good understanding on this one, because when you start developing your objective for your doctoral studies, you have to be very clear whether you're modeling for prediction or are you modeling for association, and is this towards theory development and theory testing, or is this already or is still in a very early phase like instrument development, so and scale item development. So all of that we're going to look into when we do factor analysis. The second objective is to differentiate statistical methods from statistical analysis. So this is This is something that we struggle all the time because we loosely use the word methods, or what's your statistical methods, or what's your statistical analysis. But there's a very clear difference between the two, and we will cover that. So, and then the third objective is to use appropriate biostatistical method for a given biological or epidemiological research question, or even your psychosocial, because that's the domain of nursing, is the psychosocial domain. Can I ask some of you to just mute your microphone unless you want to speak, so that we don't have all the echo from different places. So just mute your microphone unless you want to speak, and then you feel free to speak, but mute all of your microphones so that we don't have a lot of echo. Thank you. All right, so number 4 is to compare and contrast the measures of associations with measures of prediction. So I think it's very clear to us that when we do correlation study, that's association. But there are other studies that actually only tap the level of associations between variables or among variables, and doesn't really have a prediction property. So once you develop your doctoral dissertation, really ask yourself, is my objective going to examine association of variables, or do I have a hypothesis here that eventually become a theory that you are now going to develop towards prediction? Because that's a very different approach, and that's a very different way of scientific inquiry. And we have to make sure that we know the limitations of the different statistics that will really give you the evidence based on your data that you collected that your conclusion supports your theory. So I think that we have to be very careful when we develop our objectives for our doctoral dissertation. And we have to be very clear what are we trying to achieve? Are we trying to establish associations of the different variables, or are we trying to really develop a theory that will predict the phenomenon of interest? And then we will discuss basic logistic regression concepts. Regression basically is, think of a line, and you're trying to fit your variables in that line. So when someone tells you, regression, one word should be attached to that. It's a line. It's a line where, what is your way of thinking of that line? Is that a straight line? Is that a curvilinear line? Is that a quadratic lines where there are ups and downs and several occasions? And so when you think of regression, think of a line, and how does your line looks like when it comes to the different construct that you're interested in studying. So in advanced statistics, this is really the most, I think, difficult part to remember, that phenomenon doesn't really happen in one way, right? I mean, life is very complex. So for us to think that variables are just straightly associated, either positively or negatively correlated, it's a very simplistic way of looking at life. But I think as a scientist, we should always have a scientific inquiry where we always think that there has to be more than just a linear relationship. there could be a curvilinear, there could be a quadratic relationship, there could be a collinearity of the different variables, there could be interactions between the different variables. So this is what we're trying to achieve in advanced statistics, is for us to really look at our phenomenon of interest not in a very simplistic way, because I think in reality, the phenomenon of interest is never simple. The reality in life is that when that stress is not a very simple concept. The reality in life when you're interested about suicides among young adolescents, it's not just a simple concept of what are the different factors that lead to higher suicides in teenagers. So in life, these are not very simple phenomenon. These are very complex phenomenon. And when we start looking at the different factors, when we start reviewing the literature, and when we start collecting the data, a scientific inquiry should always think of multiple complex possibilities that can explain your phenomenon of interest. So logistic regressions is a very basic concept. It's a fundamental concept that there are variables that are linear in relationship, so that when one goes up, the other goes up. When one goes down, the other goes down. Or when one goes up, one goes down. When one goes down, one goes up. So those are linear relationship, very straight line, whether it's negative or positive correlations. And those are very basic concepts of regressions. And I will also point out in this quarter that logistic regressions are basically simple correlations. With appropriate modeling, you can get your logistic regressions by means of simple correlations as well. So in the old days, we teach correlation in basic statistics and in logistic regression and advanced statistics. But what I'd like to accomplish in this quarter is that for us to look at the different statistics in the same way that if we actually appropriately model and appropriately look at our variables, we will have the same outcomes even though we use different statistical methods. So number 7 is to select appropriate multivariate statistical methods for complex interrelationships among many variables. So these are now the things that we're going to look at. ANOVA. In stat 1, we basically touch on just t-test, which has 2 means, and then ANOVA, analysis of variance, which has 3 means. And we start, I think I only stopped by looking at 2 grouping variables, such as comparison of the means between male and female groupings, and comparison of the means between different regions. And so those are quite simplistic way of looking at statistics. But here in 102, we're going to look at really complex interrelationship of many variables, and then increase our sophistication in terms of looking at phenomenon. I'd like you to be more critical. I'd like you to be more scientific and more in-depth with your inquiry. Don't immediately be impressed by simple models, because I think the reality in life will show you that it's most of the phenomena of interest, especially in nursing, are very complex phenomena. When you think about spirituality, if you look at for example, bullying in nursing, or if you look at what else, elder abuse if you look at end-of-life care complexities, all of these things that are really within the domain of nursing science. These are very complex phenomena that we would like to study. And so it will be really important to look at different models with complex interrelationship of many variables. And number 8, we would like you to state and explain key concepts of latent variable modeling. So latent variable modeling, this is now some of those variables that are not really easily detectable, and these are latent variables within the concept of factor analysis. So what are those variables that group together and then create the multidimensionality of a concept? So when you look at your concept, you're going to ask yourself, is this a unidimensional? Is this really just one construct, or is it a multi-dimensional where there are many constructs within the concepts? Like, for example, when you actually look at competency, when you say competency in nursing, when you're interested in competency. So what is competency? Is that one unidimensional construct, or are there multi-dimensions of competency? And then when we start looking at competency, we look at knowledge and skills right away, right? It's like the things that we can immediately tell whether a person is competent, whether our student is competent, is by asking them their knowledge and by looking at how they perform the skills. But there are actually many other layers of competency, because we know that competency, you can have the knowledge and you can have the skills, but it's like the iceberg model. Only 1/4 can be seen in the surface. There are still about 75% that are deep at the bottom, just like an iceberg. What about the motives of the student? What about their values? What about their personality? All of that can actually contribute to the meaning and construct of competency. So what we're trying to really achieve in this quarter is to look at different concepts in a very complex way. We're going to move on to different modelings, and in number 9, a variety of advanced statistics that are considered within the umbrella of generalized linear model are your ANOVA, because that's your analysis of variance. You're using 3 means and different subgroupings, and then ordinary least square regression, which is a simple regression. And then binary and multinomial logistic regression models and log linear models. So log means logarithm. And these are for variables that are I would say they don't have the properties of normal distribution, and therefore you have to convert them into logarithm and then create a linear model. So it's a combination of logarithm and linear logistic regressions. So what I'm trying to present here is that there are so many ways of modeling your phenomenon of interest. And different statistics can really provide an explanation that will fit your model or your theory and your conceptualization of your phenomenon of interest that you would like to investigate as part of your doctoral dissertation. So all the things that we do here should prepare us to become scientists and to really question the whys, the what, and the hows. It's all of these questions must be addressed when we are doing scientific inquiry. And then, of course, the last few objectives here is to generate SPSS advanced statistic output. So this is based on the mantra in teaching statistics here in the United States that we're really moving away from asking students to do hand calculation because they have no pragmatic application whatsoever. In today's computer age, it is really, really useless to ask your student to hand calculate different models and do the math, and there's no point of that because we know that we now have computer abilities and we have infinite mathematical ability to do the calculations. So what's really important is to also build your skills in using SPSS. So to teach the different statistics in a conceptual approach so that when you understand the concepts of the statistics, you'll be able to select the appropriate statistics and then apply your skills on SPSS to generate data analytic outputs that will answer your research question. So that's really what we're trying to do. It's important that the students in statistics nowadays are taught the way how statisticians, like practicing statisticians, would run the statistics. So what I have seen in a lot of situations, in a lot of doctoral candidate in the Philippines, even masteral candidate as well, is that they have their data, they give their data to a statistician, and there is a statistician center either in Cebu Doctors or University of the Philippines or other university where they already have their own statistics department. And what happens is that the